Ladies and gentlemen, welcome to our physics revision class, and in this particular class I'll be looking at our final exam, which is physics 1015, and this was prepared by the University of Zambia School of Natural Science under the Department of Physics. So my revision will be short because I'll just look at this particular question and then move on. The question is, a rock is ejected from a volcano. By the way, this is question 5C. So if you check 2013 physics 1015 exam paper from Monza, question 5C. This is question 5C. The question is, a rock is ejected from a volcano with a speed of 25 meters per second at an angle of 35 degrees above the horizontal direction as shown below. So if you look at this stone, the stone has been projected at the speed of 25 degrees, and this is normally above the horizontal line. So the horizontal direction, it is this guy here. This is the horizontal direction, which I'll write as HD. Then there is the height, which has been put here. This guy here, the height, which is negative 20 meters, and there is also an angle down there. I hope you guys are able to see that angle. And the question is, calculate the time of flight of the rock. Calculate the time of flight of the rock. Okay, let's quickly do it and write our solutions. Okay, so with these solutions, what we are going to do with this solution is that we are first going to collect the data. We are going to collect what we call the data. Okay, so the data in this particular question is as follows. The velocity is simply equal to 25 meters per second, and then the angle, which is theta, is simply equal to 35 degrees. Okay, and then the other thing that you need to understand is for us to make sure that we know the distance. Okay, the distance d there, which I can put the sy, which is simply negative 20 meters, and then the other guy is the what? Is the acceleration due to gravity, which is 9.8 meters per second. Then what we have been told is to look for the time. Okay, now we need to look at the time. So for us to look at the time for the flight, basically we have two equations. I'm sure you guys are able to go through my lecture class. There is projectile motion lecture class 1, and then there is also a revision class. So I sent both of them. Go and watch them on our YouTube channel. So to look for time, what we are going to do, we are going to use the y-axis. Okay, so calculate the time of flight of the rock. So the time it took to fly from this particular point up to there. So for us to reach there, according to the information we have, we can simply use the equation whereby we say y is simply equal to, we know the vx, okay, we know the vy, and then e times t, which is time, and then e plus c half, okay, ate squared. plus half ATE squared. Now, one thing we need to understand, one tricky point we need to understand is also the acceleration due to gravity. If we treat distance to be negative, like in this equation, it has been treated as negative, then the acceleration due to gravity will also be treated to be what? To be negative. Now, from there, you have to apply the lecture class on vectors. Please check it up. So you're going to say Vy is simply equal to V sin what? Sin theta. Okay. So after you do that, you're just going to plug in the values. You're just going to plug in, this guy will go there. So y is the distance in the negative direction in the y coordinate. So we're going to say negative 20 is simply equal to, there you're going to replace it with that equation we made there. Remember the equation for Vy, it is simply this. This formula is also in the lecture class I gave. Then there it will be plus, okay, plus you're going to have half and then ATE squared. After you do that, you're going to say negative 20 is simply equal to, you're going to replace 25 sin 35, 25 sin 35 plus half, and then this one will be negative 9.8 according to the value we have been given, and then close bracket time, which we don't know. By the way, time there, I did not indicate it. Time there, also time there. After I work out this part, I can simply move on. So for me, I'll still have negative 20 this side. It's going to be negative 20 this side is equal to 25 sin 35. 25 sin 35, it's going to give us something like 14.34 t. Can someone confirm with me if that's what it is giving you? 25 sin 35. What's your answer? Okay, so from there, if you say that guy,
it's 14.3. The same answer you've gotten, sir.
All right, thank you. So from there, this will give you 4.90 t squared. 4.90 t squared. So these guys can go to the other side. So when they go to the other side, this will be 4.9 t squared minus 14.34 t, and then minus 20 is equal to 0. So if you look at this, you can't use the product sum factor theorem, so you're going to use the quadratic equation. So the quadratic equation will be t, which is time, is simply equal to t, which is time, is simply equal to negative b, and then positive or negative, and then you're going to say square root t b squared minus 4ac over 2a over 2a. So after you do that, you're going to identify a is this one, b is that one, and c is that one. So when you have such, what you are going to do is you're going to say t is simply equal to negative, okay, open bracket, negative 14.34, and then close bracket, positive or negative. Then you're going to have square root b squared, which is going to be negative 14.34 squared, and then minus 4. Your a is simply 9.
So there is a hand.
I'll allow you to ask questions later on. Let me just finish up solving so that I'll give you a chance to ask. So 4.9, and then you're going to have negative 20, and then there you say over 2 times a, which is 4.9. So these are the values you are going to plug in your calculations. So when you do your calculations, when you do your calculation, remember the time is supposed to be a positive integer. So after you do that, what you are going to have is that time is simply equal to 3.96 second. When you enter all these details on your calculator, your final answer has to be time is equal to 3.96 second. So this is the time which it took for this object to reach the ground. So that was the final answer for this particular question. So in the meantime, if you have a question, you are free to ask. But if you are going to have a question after this class, you are free to WhatsApp me. So for now, I will allow you guys to ask questions.